Um, so thank you so much for joining us. We're going to be covering quite an array of different things today, from the robots themselves to curriculum to equity in computer science and STEM. And I thought we'll probably just start very quickly with just introducing ourselves. So myself, I'm Nat. I'm the head of marketing at Robotical. My job is to essentially tell as many people as possible around the world about Marty and the benefits that he can bring to the classroom. My co-presenter here is Michael, who is the learning experience manager at Robotical. Michael has had a ton of experience within education, both kind of elementary and secondary, and within Robotical, he's responsible for our educational strategy and all our learning materials. And then we've partnered with Jennifer here from ProLogic ITS, who's one of the people who have been responsible for bringing Marty and Robotical to the States. So we're very excited to be kind of co-presenting this talk today with Jennifer. So I'm going to jump right in and probably just tell you a little bit about Robotical and Marty before we kick off on the more educational parts of the talk. So as the story goes, our founder and CEO, Dr. Alexander Enoch, set up Robotical in 2016. He was just completing his PhD in robotics. He's a roboticist in his background. And when he came up with the idea of Marty, his main inspiration was actually his niece, who was 6 at the time, and she was learning to code, and he wanted to create something for her that was more human-like robot that's full of character, because she was kind of learning with wheeled robots, and there's quite a lot of them around, but he wanted something that could emulate a human form. So he kind of created the prototype using his inventor skills, and he designed and built Marty from scratch. He got the all-important seal of approval from his 6-year-old niece, and he went on to secure startup funding via a crowdfund in 2016. So that crowdfund paid for the first 1,000 Martys to be put into production, and the rest, as they say, is history. So this right here is Marty. We believe Marty is the best value for money humanoid robot, certainly in the education market. Marty's unique walking mechanism means that he can walk, turn, dance, he can kick a ball, he can do so much more because each limb is controlled by a specific motor. And because each limb is controlled by a specific motor, he's also more stable and robust than other walking robots. And Marty comes with an extensive technical team and technical support from our dedicated team, and an ever-growing set of curriculum-linked lessons and activities, which Michael will cover a little bit later on in the presentation. So I thought maybe rather than talking about Marty, I will let teachers tell you in their own words what they think of Marty, and hopefully when I play this video, it will work. And the sound will work. I'm just going to give it a second to load.
The minute I brought it out of the box to show the kids, their reaction was incredible. They were cheering, they loved it. They thought, wow, look at that robot. What can it do? Can I play with it? I don't think they had ever seen a robot like it before.
For them to be able to put in code to see how Marty would react instead of having just a sprite on the screen, it gave them instant feedback if their code worked or not.
I've got pupils aged from 7 to 13, and most of the technology they're using arrives as a sealed unit. Their computers, their phones, they never see inside them. So this has been a really good learning experience.
I knew a bit of coding already, so in like a practical sense, and put against other people who knew some experience was quite nice, because I was able to see like where I was at in terms of skills, and I thought it was really fun.
Super easy to get started. The app is very user-friendly.
Younger pupils really enjoy getting Marty to interact one unit with the other, so they like to hug, they like to play football. The older pupils want to teach them to dance.
It got them using different skills, particularly in math, something that you don't always think about, in that they were estimating. So they'd plug in a number for how long they wanted him to dance, so time, or how many steps they wanted him to take, and they would estimate how far he would move.
The kids absolutely loved having a chance to get to use it, and it exceeded every expectation I had as a robot.
It's loads and loads of fun, and even if later on you can buy Marty, I'm going to go and get one and just have fun at home with him.
That wasn't quite as seamless as I had hoped, but you got the gist of it, essentially. You know, teachers love Marty, kids love Marty, and we've had such a brilliant experience in bringing Marty into the classroom. And yeah, so today we're just going to cover a little bit more about what it's like to have a humanoid robot in the classroom, why have a humanoid robot in the classroom specifically, what are the educational benefits of programmable robots. We're also going to be covering how robots can increase attainment, and not just in programming or coding, but right across the curriculum. And then just some ways in which to improve equity in computer sciences and STEM. So this is probably my favorite slide in the presentation. And just before I hand it over to Michael, we're just going to cover a little bit about humanoid robots, specifically in education. And I've kind of included some images of ones you might recognize, you know, from the news and the media. I've included Now, Pepper, and Romeo here on the right, and Sophia on the left, who's made headlines last year as the first robot to receive a full citizenship in Saudi Arabia. So, you know, they're not new. They've been around us for quite a few years in healthcare and education, etc. But the research that we've done specifically that's been written about using humanoid robots in the education center, the reality is that it all comes down to the fact that the students and most people, they can connect with and relate better to something that they perceive as looking and acting like themselves. They're more likely to be more engaged, more empathetic. And for children on the spectrum specifically, there's been a lot of research to suggest that humanoid robots are especially effective in supporting communication development and social and emotional skills development. We also know that humanoid robots help children concentrate, and children were reported to be more motivated and have a more positive attitude when having those robots in their classroom. And there's also studies to suggest that humanoid robots help children to make real progress in various areas of learning, like I said before, beyond coding. So in reading, writing, non-native language learning, reasoning, and the learning by teaching approach that was used in this specific study that I'm citing was just as efficient in very young children, as young as 3 years old, as it was in teenagers. So I'm going to hand it over to Michael, who's going to talk specifically about increasing attainment in the classroom. Michael, are you there?
He's just muted right now.
Oh, dear. We have had that.
I forgot my microphone icon in the screen here for the hop in. I had all ready to go everywhere else, just not there. Sorry about that.
Oh,
just saying. I'll say again because you didn't hear me the first time. I've been in education, as Nat said, over 20 years. I started teaching in 2000. No, I started teaching in 1999. Sorry, in Canada. I've taught in Canada, England, Scotland, and Poland, and I have had experience in primary, in secondary, elementary. Sorry, in secondary. And actually, this brief stint with some university students as well, covering their mathematics there and working with some IT way back when I was living in Canada. That's a long time ago now. With this slide here, I'll talk about what you have for your common core subjects. So raising attainment, I'd say in the US, from the work I do in the US subjects as well, often focuses on the core subject of mathematics and English language arts. There's several places where Marty aims to support attainment in these areas. Estimation is critical. when designing code that involves distances traveled. Angle awareness is addressed when conditionals or if statements trigger different movements or looks. Integers are explored when learners investigate the range of movement from Marty's joints and motors. Instructional sequences are at the heart of code development. In much the same way that order is crucial for a recipe or manual, code can be broken or return the wrong results if the steps are not ordered properly. Awareness of punctuation and spelling, though a very small thing, can have dramatic effects on code. For example, the word orange with a capital letter and a lowercase letter are not the same thing when you're programming. Additionally, teachers often use objects as motivation for creative writing, a stuffed animal or other toy that went on an imagined journey. Marty can be that and more. Have Marty react to actions, sound, light, and noise to inspire writers' creativity to create other scenarios. Set problems or tasks that have more than one solution and share the different routes your learners have taken. Discuss efficiency and improvements and celebrate the success of different paths. Set challenges that require thinking and application across different disciplines, and see Marty carry out the results of the investigations. If the result wasn't perfect, think again and make it better. Here's an example showing a school called St. Mark's Primary in Irvine, which is in the UK. This is a school that was sharing that more than just in terms of literacy, there was support given to a range of areas. It covered several aspects of numeracy, writing, other areas of mathematics too, and as is alluded in the mention here of directional language used, really supported a wide range of things. Working together is a crucial skill for developers who regularly engage in paired or mob programming. Teamwork features in every learning experience designed from Marty. Teamwork is at the core of all the lessons as we go, because it really does take a team to work with Marty in the classroom setting. Using approaches like cooperative learning, pupils can see the strengths of the whole group. Additionally, the idea of group success is consolidated with each coding attempt that gets one step closer to the goal. Pupils will have opportunities to think outside the box and will grow in their acceptance of ideas that are different, because different may be just what was needed to achieve success. Practice is crucial for developing and maintaining lasting progress in learning, whether it's based on literacy, numeracy, or other areas of the curriculum. Marty's learning experiences present regular opportunities for seeing the learning. Without an understanding of numeracy, we wouldn't have been able to properly code the if statement's parameters. Without proficiency with sequencing instructions, we wouldn't have written successful code that met all the requirements of the task. And without effective teamwork, we wouldn't have appreciated the benefit of looking at the problem from a different perspective and increasing the efficiency of the code. This chart shows a regular progression through the CSTA standards. Each step can be supported by Marty the robot. For beginners, Robotical's learning experiences start by introducing screen-free coding, where learners will develop their understanding of creating instructions and seeing them carried out. The next step is the introduction of symbols that instruct Marty to act. As you can see here, we have the control panel, which is part of the app from Marty, causing him to go forward, back, left, and right. Learners at this level will work together with blocks, where Scratch Junior also comes into play. More complex coding ideas, if statements, loops, and logic blocks are introduced with screen-free activities and then in Scratch, as you see on the screen now. Learners will expand on the condition statements and loops, creating compound conditional statements and nested loops. Additionally, parallel programming will be used to enable multiple movements from Marty. And using variables makes code more responsive as it runs. The next stage of learning introduces functions. When paired with parallel blocks, learners can explore the myriad of options they have to write efficient and reusable code blocks. Learners will start this phase with Scratch and may progress to a text-based language like Python. The final step of learning offered through Marty makes full use of text-based programming. Learners will gain experience with syntax, language formats, and documentation that will serve them in potential future careers. Also, add-ons like a Raspberry Pi can lead to more complex creations. And I didn't mention here too, but earlier on we do have use of the microbit with Marty, depending upon the connections that you have available. This sample video.
I'm really hoping this works better.
I hope so too. This sample video shows how Marty can be used across the first few stages of learning. Now, when it's going to go here, you're going to see Marty reacting to the cards, and I'll explain what's going on as Marty starts moving. I wrote programs lessons for these youngest learners to focus a lot more on thinking as a computer might, rather than delving into the code vocabulary or the code complexity or even the coding words. It's more about the steps, it's the recipe. So here the color cards have instructions built in. Learners have no need to write or read the coding vocabulary. Learners are practicing sequencing and computational thinking. As you see here, although it's a bit choppy still, the green card cause Marty to go forward. The blue card cause on the side up to the left. The yellow card moves them backwards. The purple card is reaching this now will cause them to move to the right. And the red card at the end stops them and commands them to perform a celebratory dance. So these 5 cards come with Marty the robot to have learners engaging with that idea of computational thinking. The second part of the video here shows Scratch Junior in action. Learners are coding now, but it's a symbol-based instruction, so they have the arrow keys they're using there instead of the colored cards. They still don't have the pressure of reading the code blocks. They're not having to understand the words like forward or backward or reading them. They're just using the symbols. This sample is a single sequence without any conditions at all, just to reach the goal of the other Marty there. The third part of the video here is slightly more complex. In the example here, you can see on the side there, which is what you'll have available in the teacher guides. There's evidence of nested condition statements given loops. You'll see Marty carrying out separate actions depending on the values received from the distance sensor that is installed on his foot. As the distance changes, Marty to the object, Marty's actions change too. So here you see Marty react differently depending upon the results he's going through. We want educators to engage with the lesson so they can be encouraging the learning to the best of their ability too. This is supporting both the educator who's going along with the learners as well as supporting the learners in their journey. The lesson plans will show the code in action and often have parallel views of the code in Scratch, Scratch Junior, or Python alongside Marty, so the teachers will see the code as an example, as a goal that they should achieve, but not necessarily the right answer, because there are so many. Early learning, each learning experience includes a teacher's guide. This is all the necessary code needed for the lesson, as well as descriptions of what's happening in each program and what each part means. All lessons are aligned with various national and regional curricula, including CSTA and the ISTE standards. Additional state standards are also part of our future plans. Additional content includes a workbook for learners for each lesson, and graphics or handouts that support and extend the learning. And finally, each lesson pack includes a presentation document. This is a PowerPoint presentation that can be used to encourage discussion in the lesson. We're currently writing each presentation to include graphics and video to share with the learners, and there's also always a section of notes at the bottom to give you some talking points or some ideas for questions or ideas for what the learners might say to you so you can be prepared. Each lesson includes a section for support and extension. This is the key thing again. It's not just a case of one or the other, because there's a range of learners you'll have in your classroom. Because learners have different experiences and abilities, it's important that those who are able should be encouraged to go beyond the objectives and success criteria of the lesson that you've set. Additionally, those needing support should be given it in order to achieve success for the shared objective, stated objective, and the success criteria. So it's not a case of having a whole different lesson. The objectives are the same for the class. Those objectives are achieved, then they can go beyond. Those objectives are helped to be achieved, but it's not a case again of having a weaker or easier objective for those needing support. We want everyone to achieve, we want everyone to grow and learn as the journey goes with Robotical.
Thank you for that, Michael. And I'm sure we'll need to take some questions from you at the end, but I wanted to jump back in just now to kind of tie what we're talking about back to what the summit is all about, and effectively, talking about bridging the gap and making computer science more equitable. And this section may be a little bit of preaching to the choir, and you'll already be familiar with everything I'm about to say. But from the research we've conducted, it's very clear that there are 4 key ways to improve equity in computer science and STEM education. And I'm just going to take a step back for a second to earlier this year when we polled over 100 teachers in the UK. And I'd imagine that the findings would be quite similar in the US. We asked them about STEM education delivery in their schools and what are some of the barriers that prevent them from delivering STEM education successfully. And as you can see, 80% cited resources as being the biggest issue, primarily because of funding, followed by teachers being unfamiliar with teaching STEM and therefore not confident enough to deliver those subjects. And those are just 2 of the biggest contributing factors to the lack of diversity in STEM. And then when we kind of drilled a little bit further in terms of the learner engagement, whether or not they felt there was a gender bias between, the interest in boys or girls, yes, 57% said no, there was no gender bias, but I find it still alarming that nearly 30% felt that there still was. And they, when we asked them exactly why, they said all the things that we already know and we've talked about extensively today. It was preconceived notion. It was, the notions that STEM is for boys, it's not for girls. It wasn't as exciting for girls. It wasn't as accessible. And so we really wanted to understand what it is that we could do specifically for us as a company to really encourage STEM learning and education further on into secondary school for girls. And the kind of 4 things that we found again and again in how to make STEM education more equitable is the number 1 was that the earlier children are exposed to the subject, the less scary it seems. So when they don't have exposure to computer science until high school, it can be very, very daunting. And by introducing computer science to elementary students, they'll feel more confident, more prepared when the curriculum gets more complicated, and they'll know what to expect because they've had a chance to build such fabulous foundation in computational thinking earlier on. So really, by the time you get to middle school or high school, it's really too late. You need to offer computer science education earlier in the journey. The second thing, and this very much supports what Michael was just discussing in terms of extending or supporting the students, is that, everyone learns differently. And from your own experience, if it's too easy or too hard, you'll completely lose interest. So each individual should be encouraged to progress at their own pace. And Michael's already mentioned how we do that within Robotical's learning and teaching resources. The third one that kind of became very clear, maybe not so much in the UK, but certainly in the States, is, when we spoke to different districts, we found that only some schools had access to computer science education, and only some grades within those schools had access to it. So the biggest reason that was cited for that was lack of funding. Not every school had the funding that was necessary to implement computer science for all students, and that's a real problem. But the good news is that there are great opportunities to secure funding for computer science education. We'll come to some examples in just a moment. And kind of the fourth biggest thing to really make computer science education more equitable is just to introduce diverse role models. And, we know that it's important for students to see people who look like them working in STEM. And it makes it easier for them to consider those jobs as their careers, if they can visualize it, if they can imagine it. And Robotical does a spotlight series each month where we introduce a STEM hero from a diverse background on our channels. So this month is the LGBTQ Pride Month. So we introduced Lynn Conway, who's a computer scientist, inventor, trans woman, an activist for transgender community. Last month, we celebrated Asian Pacific American Heritage Month with a spotlight on Ellison Onizuka, who in 1985 became the first Asian American, and I believe also the first Hawaiian in space. And for International Women's Day in March, we had rocket scientist and mathematician Annie Easley. So there are many ways in which you can help students discover their role models very, very early on and be able to visualize themselves in those professions. And I think just, quickly before we finish, just to kind of talk about some funding opportunities that are available in the States. Some of those you'll be familiar with. So obviously the US Department of Education releases grants very regularly. We've also come across Skills Start to work to advance equity in computer science by a matching grant that they provide. There's also the NIA Foundation and their STEM grants for different districts. And the last two on the list here we found on the nsf.gov website. But we do have quite a lot of we have lists of funding opportunities on the Robotical website and blog as well, if you wanted to head over and have a look there. And yeah, I think, Jennifer, if you wanted to say a few words just now in terms of trialing Marty and just having access to Marty, if you teach STEM and computer science in the States, I'll hand it over to you just to say a few words.
Of course. Thank you so much. It's always a pleasure to be with the Constellations. It is a powerful platform, and y'all spread so much great information to, on this platform across the nation and internationally. So I want to definitely give a thank you to Lynn for pulling this together. I know it's a labor of love and passion. I wanted to kind of tell you a little bit about my story with Marty and why I'm very passionate about Marty and the changes that I've seen children, how he's facilitated through using, and again, to your point, Natalia, starting children at a very young age. He's so easy and powerfully wonderful to work with. And for when you're working with students and you actually get to see them engage and make Marty move and have him code him to dance, it's just kind of like magic in the room. I was a teacher for 7 years and taught a structured reading program. So it's a lot like your students learning to read that first word. It's very powerful, and it's just a blessing to have students have this exposure to a robot that they can connect with at such a young age and grow with. So on top of the beginning coding, using Scratch, moving into Python, moving into Raspberry Pi, all of these things just are phenomenal to have students grow with and be able to have more use of the sensors with Marty. And the newest version, the version 2, is just phenomenal to see in action. So I am actually local, and I work a lot with Fulton County schools and Atlanta public schools, and really want to facilitate any type of help that school systems need and districts to learn more about Marty and get it in front of students, and really start our students as young as possible and have them so happy to learn kind of the gift of coding. So please feel free to reach out to me, and I'll help facilitate and support you in whatever your needs are with having Marty in the classroom.
Thank you so much for that, Jennifer. Yeah, we'll open the floor to questions. We do have a few questions that were submitted ahead of time, but I'm happy to take any questions if people wanted to throw them at us just now, either in the chat or come on the stage. Okay. One of them that someone had pre-submitted has to do, and it's one that we hear quite often. And Michael, this one's for you, but it's basically what benefits do humanoid robots have that wheeled robots don't? And does that necessitate that kind of investment? I guess what they're referring to is obviously, the price difference between Marty the robot and something like, Sphero is vast. And so potentially, if you wanted to speak to your experience, Michael, in terms of the classroom and what you found when you were teaching. You're on mute.
There we go. I just turned the camera off. When you start talking and it's muted, it puts this big text box over top of the icon, so you can't see which one the microphone is, so you can't turn it on.
That's
Fun,
bad UX.
Okay, so for me, as a personal experience, and this isn't going on research, this is going on me being a teacher for many years and talking with other teachers too, and seeing teachers not engaging with the resources that we had in the school. We had a turtle robot, and it was a kind of a square thing that had 4 buttons on its back, and you could tell it to go forward, you could tell it to turn left and right, and you could tell it to go back. And that was it. So what you had was a case of giving instructions to something, causing it to move, and there was one for a class of 30. Now, I couldn't tell you the price of them, but I would imagine it was not exorbitant, but it wasn't used. It was so infrequently used in school. So we had most of any coding work that we did in primary school in Scotland, where I was teaching, it would have been all on the screen, and it would not have been seeing something move in real life. That connection to having a effect on a physical thing and seeing that physical thing move in a way that a person moves is magical. I actually recall my kids and I, we went to a science festival in Scotland, and we also went to Japan for my brother's wedding of all places. And they have some amazing science and robotic stuff there too. And their connection, immediate connection with these robots that were humanoid. They were not quite their height, a bit shorter than that. They're the ones who played football quite a lot on television. They have teams. It was remarkable how much attention they held from a group of kids, 30 kids, just watching it move. And that was that draw. It was enough to have that human-like connection, something obviously not human, but it was the size, it was the height, it was the limbs, it was the head, it was the body, versus the robots you often have in school that are programmable toys that don't emulate anything that we do. They don't represent human at all. And it's really difficult to have that connection with a block, with a square. It's really difficult to write a story about a square or think of a square going on an adventure. Whereas with Marty can be so encouraging for creativity, for imagination, and for a connection in terms of communication. Nat had stories that she's visited in schools too, or heard of some schools where stories from teachers, I should say, where the teachers have said there are some learners who had difficulty communicating in class, and they would talk to Marty. And it would be, again, that imaginary friend you would have, or your stuffed bear, and you would confide in them. The teacher saw that the children would be easily and comfortably engaging with this device, this robot. And I think a very, very large part of that is how the robot is made. The robot has 2 arms, it has 2 legs, there's a head with 2 eyes, there's a mouth, and all these things together make it something that I can see. I see your face, and you're looking at me, and there's a connection there, and it's lovely. In the work I've seen now with the learners in Twitter, you'll see, if you ever look at Robotical on Twitter, you'll see a plethora of examples of young children and older children too, engaging with Marty the robot, watching him dance, and see the joy that they have when they achieve what they set out to do. It's remarkable. Even the joy that they have when they first have Marty move. It's as easy as that to get the connection. This is why I'm working here too, because I love it this much. I find it a way to really inspire kids, and hopefully what I'm doing is going to be supporting the adults, the educators, to bring that experience for younger learners and for older learners alike. That was a very long answer, sorry. See, did you
Right.
just
horrible UX just there, an example of very bad user experience. Whilst you were talking, that reminded me of a specific testimonial that we had from a additional learning needs principal at a school here in the UK, and I just wanted to read out his testimonial because it's very apropos to what you were saying. And he first talks about the Marty being used across the school, and then he goes on to speak about it specifically with children with additional support needs. So Marty has proven very beneficial when working with children with additional support needs. Haresdale Primary has had many children with communication difficulties who find it hard to express their feelings and emotions. Marty has provided an opportunity to develop communication skills with these children as they're keen to share and communicate their thoughts and feelings with them. One boy in particular was very upset and couldn't explain why to an adult. When I introduced him to Marty, he was more than willing to explain everything to him. Being able to surreptitiously code Marty to respond sympathetically to the boy also encouraged this interaction. Many of the children with additional support needs treat Marty as a friend and as part of the class. There's a whole range of possibilities to use Marty as a communication support for children that we're only beginning to explore. So I thought that was kind of quite interesting to bring that up just now. And thank you, Lynn, for that as well. Yeah, we have a newsletter that you can sign up to on the robotical.io homepage, and you can have access to our white papers once you do that. So we do have white papers about specifically why humanoid robots in education, and we also have a white paper to help you write successful funding applications and grants. So those are accessible from the homepage. I don't know if anybody else has any other questions. I know this is quite a short session compared to the time that we were allocated. But if no one else has any questions, perhaps we'll let people go a little bit early and have a bit of a break before the next session in 20 minutes.
I guess that would be okay. But to the audience, there's no one with any more questions? So we've gotten one. Can you tell us more about the hardware?
I could, but I wouldn't be the right person to do that. We have a whole team that has created the hardware. So as I mentioned earlier on, Marty was created by a roboticist. So Dr. Enoch has a PhD in robotics. He did his PhD on walking robots, and he specifically created this walking mechanism that is unique to Marty to ensure that he's more stable than other walking robots. And there's 9 smart servos in total. They control each one of the limbs, and there's a couple in each leg as well. So you can even move kind of each limb independently. So Marty can sidestep, he can balance, he can, do a wiggle, he can do a dance, and that's all thanks to the different motors. So it becomes a little bit more complicated when you go into Python, because you can really kind of focus on each one of the movements and what it is that you want Marty to do. But it's also simplified for younger students in Scratch Junior and Scratch. So you don't have to have the technical know-how to be able to use Marty, but you can take it all the way up to kind of post-secondary education. And students have used ROS, which is Robotics Operating System software, with Marty to teach him almost to be autonomous and to have vision with a Raspberry Pi and a camera, and to be able to play soccer with other Martys. So the possibilities are endless. So it's almost like a very simple robot to use, but he's still very state-of-the-art at the same time.
An additional thing with regard to the hardware is that there are a number of add-ons you can use with Marty in Scratch. So just now, I'm not sure what's on the feet just now that you have there, Nat.
I have a color sense, an infrared foot, and a color sensor.
So these two here are for telling if there's something's in front of Marty or if nothing is below Marty. So if he comes to the edge of the table, you can program Marty to stop, so he won't fall off the table. And the color sensors I showed in that video there, when you had the color cards, these are screen-free coding cards. So you press a button on the back, or you enter screen-free mode with Marty, and you have him walk on those cards depending on which color he hits. Additionally, there are lessons written in the Robotical site that have older learners writing their own code to develop a screen-free Marty. So they're telling Marty how to interact with those cards. So they can show it to younger learners. This is how Marty can work with the color cards. And their code would be different than the built-in code in Marty's hardware. They'd have the software to say, okay, we're going to have the green go this way, or the blue do that thing, or the red make this noise, or something like that. In addition to those sensors there, the colors and the IR, there's also a distance sensor, which comes out under his chin when it's installed, and it measures quite more accurately how far away something is. So you could use that in Scratch again to have the Martys interacting. And the example, again, in the video you saw in the box move closer, that was with the use of the distance sensor. And as the box became closer, Marty, based upon the nested the compound conditional statements, he was doing different things. So that was the distance sensor. There's also lessons for the noise sensor, and there's a light sensor. So depending upon how your environment is in terms of noise levels there, he's going to do different things. And with the lessons that are prepared for that as well, there are real world implications. Why would I have a noise sensor? What is a noise sensor? How does a noise sensor work? Who uses a noise sensor? So it really does get into the nitty-gritty of the hardware we're using with Marty. Not just a case of, here's a noise sensor, make Marty do something. It's, what's a noise sensor? Why would I care? And there's examples I'll give you of when you have, for instance, with a noise sensor, it's a city, and there are environmental controls. If the noise gets too loud, the environmental health officers are alerted to that, and they come out to investigate why it's so noisy. And they put in place in their plans for the city to make things better. They want the city to be a cleaner place in terms of noise, and they want to find out what's making the noise. So they might do some traffic changes, or they might encourage some earlier home, or they might encourage some shops to close earlier, or something like that to make it a healthier environment. With a light sensor, again, that's an example of when I have in there, when you walk past something, or when the light gets dim outside, your light turns on automatically. These are examples of light sensors in action in the world. That's what happens in our world. So how can we have Marty react to the light changing? Well, this is what we can do. And in the lessons that I've written as well, there are examples of when you have the code working for the educator to see, and they can see the code running. And they'll see as well the examples of what that part of the code means. So if a learner asks a question, you have the answer at your fingertips. We want to empower the educators to be confident, to inspire that drive in their learners, so that they feel our teacher knows what they're talking about, because they will know what they're talking about. I feel confident, I'm excited, I want to keep going farther. And like I said, again, those extension activities, they're the perfect place for that, because they do present then a place where you need to do this yourself now. You've got this outcome, you've done it, fantastic. Now, I'm not telling you to go away, I'm telling you to go higher. Push yourself, because you can. And that drive, that we don't want to stop you sort of message that we're giving to the younger learners is, why would you want to stop if you got it already? There's something more, there's something bigger. Keep going, because you can. And that love, or that energy, you want to really encourage it and keep it going. That's a big part of it. The hardware is wonderful, how easy it is to put onto Marty, how easy it is to quickly interact. And the app that's been built by the developers, amazing stuff that they're doing, and always improving it too. It's so quick and so robust and so easy to see where things are, and then in Scratch to use them properly. And I'm hopeful that the lesson videos that I have will nicely outline where to find everything, where everything goes, and how it can look to make it the best result.
Yeah. I've included a link as well to our All About Marty landing page, which effectively talks to, which sensors come with Marty as standard, and which sensors you'll need to buy, to purchase, to be able to put onto Marty as an extra. But aside from all the sensors, we should probably also mention the disco LED light.
Disco.
Everybody's favorite. Yep. Marty has LED lights in his eyes, arms, and feet that can light up based on a sequence that you can build in Scratch and Python. So you can either get the eyes, the arms, the feet, or all three all together, and that has been really, really popular.
One quick thing, jump in again too. This is the part I like about the disco lights. Not just the fact you can have a dancing disco Saturday Night Fever sort of Marty in your class, which is really cool. You can also take those lights and use them for mathematics. I have an example lesson in there where you have guess the secret number, and as you get closer to the number, you're raising Marty's arm to make an angle. So as the arm raises, your angle's increasing. As the angle goes higher, you might get warmer, and so the light goes red. And if you get colder and farther away, the light goes blue. So it's again that whole game of warmer, boiling over. Oh my God, you got it! And you guess the right number. And it's that again. You're seeing the feedback right away. You're seeing when your angle's increasing, so the arm is moving. You're also seeing if you're getting closer or further away. So if you overshot it, like you guessed 110 degrees, oh, it's too high. It goes red. It's too far. But that sweet spot is when you get the flashy lights. Disco, disco, disco. And it's that the funness comes into it and the excitement comes into it and the question and the discussion, which is really what you want to be encouraging, because developers don't do it solo. Developers do it largely in teams. They do it in pairs, they do it in teams, and they work together and they talk a lot. It's not a library.
Yeah, no, definitely. And I mean, we could talk about the different functionality of Marty for absolute hours and everything that Marty can do, but it's all there for you on the website if you want to have a quick look. I guess the other thing that we should mention is that any school that's looking into investing in new STEM resources can have a free 2-week trial with Marty. And you can get in touch with Jennifer. You can get in touch via the Robotical website, and we'll facilitate that 2-week trial with you. And that comes with one-to-one training via video calls with one of our educational experts, all the technical support that you would need in unboxing Marty, highlighting the lessons within the lesson plans, because there's a ton. So really depending on what you want to teach and what level your students are at, our educational experts will be able to highlight which of those lessons or lesson packs are perfect for you. So we're happy to do a no obligation 2-week trial and cover all the costs of shipping and returns as well. So if there's no other questions, I think that is us. Would you?
Yeah, and I just want to thank Hal too for adding the Scratch Robotical link, because that's a little bit of magic in that link, so you can actually see how fluid it is to introduce Marty and how quickly your students will be able to pick it up. So.
Thanks for sharing that, Hal. I wasn't sure that was something we should share, so it's great. This is actually Scratch Robotical Day. That's where I go to build a lesson plan coding. So I'll use that platform there for the lessons you'll see on the site. There's a new format that I developed. So there's the lessons you'll see as you go through. They'll feature video. They'll feature the PowerPoint presentations. These are the ones that I put in place, and that's where I go for my coding. It's a great place to go.
And Lynn wanted me to mention that you all have a virtual booth in the expo, and to tell people to go and check out the expo and find out more information about presentations and some of the presenters here, as well as other companies that were interested in companies and organizations that have information there. So with that, I thank you. Again, you just have me more interested, and I'm going to have to now ask Lynn, when is she going to get us some?
It's really fun and quite addictive.
I can tell that. So I was hoping she was still here and caught that hint, but that's okay. I will let her know. But I appreciate you all for taking the time out to come today. And with that, we have just a little bit of a break. The next sessions start at 4:25. So if you would like to get ready to start transitioning to those, I'd like to thank the team for coming today. And I am sure we will see more information about Marty being spread.
Thanks everyone for coming. Lovely talking.
Thank you.
Well done. That was a lot of fun.
That was a lot of fun. Yeah. I was like, come on, people, ask us questions. We want to answer them. Yeah.
I've been on a couple other ones, other sessions, and the audience is kind of quiet today. So I think we actually had a pretty rowdy bunch. So I love the people popping in from Argentina. I mean, this is great. And Michael, thank you for hitting just the key points. And Natalya, y'all are a great team. So
thank you. Yeah,
appreciate all your support with this.
No worries at all. Yeah, if anybody comes through and wants a free session, let us know and we'll facilitate it with Ben and Miles and the team. And yeah, happy to do
I know. I mean, y'all are a joy to work with. So always, yeah. So I'm sure that we will have some people that are interested shortly. So we'll be in touch.
Yeah, thank you. Have a great rest of the day.
Thank you. Have a great one too. Bye.